The 18th century had begun with horse-drawn carriages and rudimentary sailing ships. By the dawn of the 19th century, a new era was on the horizon. The Industrial Revolution, marked by unprecedented technological advancements, was sweeping across Europe and America. At the heart of this revolution was a hunger for innovation and a thirst for efficient power. This insatiable need gave rise to one of the most iconic symbols of the era, the steam locomotive. Before the advent of steam, transportation and industry relied heavily on animal power, human labor, and the unpredictable whims of nature. Factories, often situated near rivers, harnessed water wheels for energy, limiting their location and scalability. The steam locomotive emerged as a beacon of change, promising a future unshackled from these constraints. Its development was not a singular event, but rather a culmination of incremental discoveries and refinements, each building upon the last. Early pioneers like Thomas Savery and Thomas Newcomen experimented with steam power, laying the foundation for the revolutionary engine designed by James Watt in the late 18th century. Watt's engine, with its separate condenser and increased efficiency, proved to be a game-changer. It provided a reliable and controllable source of power, paving the way for its application in locomotives. The steam locomotive was not merely an invention, it was a testament to human ingenuity, a symbol of progress, and a catalyst for profound societal and economic change. It redefined the limits of speed and distance, shrinking the world and connecting communities like never before.
At the core of every steam locomotive resided its beating heart, the steam engine. This ingenious contraption served as the muscle, converting thermal energy into the mechanical force that propelled the locomotive forward. The principles governing its operation, rooted in the laws of thermodynamics, were elegantly simple yet remarkably powerful.
The process began with the generation of steam. A massive boiler, typically housed within the locomotive's belly, acted as a pressure cooker. Water fed into the boiler was heated by a roaring fire fueled by coal or wood, transforming it into high-pressure steam. This steam, now a potent force-seeking release, was directed into cylinders. Inside these cylinders, the steam's expansive energy pushed against pistons. This linear motion of the pistons was then ingeniously transformed into the rotary motion required to drive the locomotive's wheels.
This transformation was achieved through a system of rods, cranks, and linkages, each component meticulously engineered to withstand immense pressure and repetitive stress. The back-and-forth thrust of the pistons was converted into the circular motion of the wheels, much like a foot pushing down on a bicycle pedal translates to the rotation that propels the bike forward. This seemingly straightforward process of converting heat into motion was, in reality, a carefully orchestrated dance of pressure, timing, and mechanical precision. Every hiss of escaping steam, every clang of the piston, was a testament to the intricate interplay of physics and engineering within the locomotive's iron heart.
Beyond the fundamental principles of the steam engine lay a treasure trove of mechanical marvels that transformed the locomotive from a concept into a powerful reality. Each component, from the massive boiler to the smallest valve, represented a triumph of engineering ingenuity designed to overcome specific challenges and enhance performance. The boiler, often considered the locomotive's heart, was a feat of both material science and design. Constructed to withstand immense internal pressures, it featured an array of tubes and flues that channeled hot gases from the firebox through the water, maximizing heat transfer and steam production. Equally ingenious were the valve gear mechanisms that controlled the flow of steam into and out of the cylinders. These intricate systems of levers, rods, and valves acted as the locomotive's brain, precisely timing the entry and exit of steam to ensure optimal power and efficiency. The development of advanced valve gears, such as the Stephenson valve gear and the Walschaerts valve gear, significantly improved locomotive performance, allowing for higher speeds and smoother operation. The translation of linear piston motion into rotary wheel motion relied on robust crank and linkage systems. These mechanisms, designed to withstand tremendous stress and strain, showcase the elegance with which 19th century engineers tackled complex mechanical problems. The robust construction of these components ensured the reliable transfer of power from the cylinders to the wheels, enabling the locomotive to pull heavy loads and conquer steep gradients.
The steam locomotive didn't just revolutionize transportation, it transformed entire industries and societies. By drastically reducing travel time and cost, it opened up new possibilities for trade, migration, and communication. The ripple effects of this innovation were felt far and wide, shaping the modern world as we know it today.